So I'm Pandora Boxchain core developer, and what are we doing now in Pandora? So right now we are developing blockchain level proof of stake consensus protocol. And why are we doing that? Because we are not satisfied with existing protocols, consensus protocols, and we have some ideas how to improve them. Our science guys are in the process of describing and formally verifying this consensus. And for the last 5 months, I've been developing Python simulator to test this idea that we have and to see what works and what doesn't work from engineering perspective. So my motivation to give this talk that I want you to feel what mindset is required for developers when you're trying to develop your own consensus. Consensuses might be, and blockchains in general, might be a little bit difficult for you if you come from another field and if you are used to thinking like in client-server perspective. And I think that everything is easier to be imagined with real-world objects and phenomena. So let's take, for example, this room. And let's pretend that it has a blackboard here. And there are people standing outside and they want to make payments. And also, let's imagine that you are here, all are validators. So people who want to make payments, they take a little piece of paper, they write their name there, they write the name of recipient, amount of money to be paid, and they just throw it here. So all the floor in this room is like covered with payments. So what we need to do? We need one validator to get up, to get to the blackboard, to get up and take some transactions from the floor, like these pieces of paper, put them on the blackboard, and sign this thing. But we have to come up with ordering who will be first. So in Bitcoin, you have to do this time-consuming computation. Like you have to solve some task, and whoever does it first will get to the blackboard and put this set of transactions for everyone to see. But in proof of stake, we try to eliminate this need, and that's why we introduce random numbers. So random numbers will be collected from the history of blockchain, but since we are only starting, we don't have these random numbers, and we don't know how to order validators, who will be first, second, and such. That's why we will put this information into Genesis block. So Genesis information is like initial parameters for our network, and this information is scratched on the blackboard. It cannot be rewritten. It's super immutable. And in this example, in the Genesis block, we have ordering for our first validators to kickstart the consensus. This is Genesis. So the process will go as follows. So validators get up from this chair. One of you, for example, Olga, are going to be the first according to the Genesis. She gets up, she collects enough of these papers, comes to the blackboard, puts as much as she could, and signs with her signature. She also has, before she does this, she has to check if there are double spends. If the guy who wants to do the payment tried to spend the funds he already spent, and if he or she had enough funds to begin with, she leaves the signature, and we all here, and including the guys outside, have to check this for correctness. We have to check all these things, and we have to check that validators didn't cheat and put everything properly. And also, the very important thing that we all have here little notebooks, and we put like redraw from the blackboard to our notebook this block that was put on the blackboard. So what do we have now? Like we have the network is the guys who are standing outside. They want to make payments, and they have to watch validators that they don't cheat and don't do bad things, malicious things. And on the other hand, we have validators who, when they get up, they grab these transactions, they check everything for correctness. And also, these guys outside can penalize validators by excluding them from the consensus themselves. So like they see that someone's cheating, they not just only do not redraw the block from the blackboard, they just put a little note that this validator is malicious and we are like banning him from the consensus or her. And also the guys outside and you all inside can see this initial state, which is called Genesis block. Like we put this initial state into Genesis block. So we know how to kickstart consensus, who will be first, second, and stuff like that. So, all right, the next important thing is staking. So you all here become validators just because you were in the initial state. But every participant, if they have enough money on their wallet, for example, they can send a special type of transaction which called stake hold transaction or something like that. And they write their name, amount of money to stake, and these funds are frozen. Validator. So yeah, these funds are frozen, and they can become validators, become one of us, and they can also start grabbing transactions here from the floor and putting them onto Blackboard. And about random numbers. So this ordering that was before in Genesis block have to be somehow generated from the history. So we divide our blockchain into 10 blocks, and we call these 10 blocks an epoch. So 10 validators, which were, for example, first validators, are shuffled, and their order is not determined. And we choose the last 5 to be generators of the random. So it looks something like this, for example. So these last guys have to send their cryptographically encrypted random number at the time that first 5 blocks are signed. And they send it in arbitrarily order. And after first 5 blocks are finished, they have to show us the key by which they encrypted this random number. And when the whole epoch of 10 blocks is finished, everybody on the network, both validators and the payment makers, can independently unveil the random number that was there. And for example, we can add this number, and we will get a random number to produce sequence of validators for the next epoch. Yeah. So let's revise a little bit. What do we have in our little abstraction of what consensus is? So we have these outside guys. They made payments. We all here validators. We have Genesis block to kickstart our consensus, and Blackboard to broadcast our blocks, like these transactions that we consider proper, correct? Yeah, and that's it. And I want to ask you to know if anybody has question on this side, because I'm going to go a little bit more developer stuff. Anybody has questions? All right. So what to keep in mind if you're a developer and want to develop your own consensus? So we developers look like this usually. We have our assumptions about our consensus. For example, in Bitcoin, there is an assumption that 51% of nodes are not malicious. And that's how it all works. In our consensus, for example, that we are developing in Pandora, we also have the same assumption. All widely used pure proof of stake consensuses, they say that 2/3 of network should not be malicious. So we're improving on this thing. We also have to think about time in which we are waiting for the message from validators, or not from network, only from validators to come, or not to come. So we have this time limit, and we always have to keep it in mind. We also have to come up with strict and consistent rules of how things are happening in our network. For example, a very famous rule in Bitcoin consensus is called longest chain rule, and it states that that longest chain is also considered the main chain, and nobody, if there are 2 concurrent chains, the longest chain will be main, and nobody can change that. It's a simple rule, but it has its own downsides, but it works. And also, as developer, we have to come up with fields which will be sent. For example, if you want to make payment, you have to write name, you have to write recipient name and amount. These are fields that have to be told to the whole network to come up with the right way to work. Also, our consensus will always be under attack. You have a question? Sure.
So you have this assumption that 2/3 of the network should not be malicious. How do you come up with that?
This is not our assumption, but it works. You mean like how do we calculate this number? I'm not really sure about this. We have a guy who works with this, who like comes up with this crazy stuff, and let me think. For example, in our we have not 2/3, we have 51%, and we have this algorithm called Shamir secret sharing. If you ever heard of this, and it works only if you provided more than half of needed parts to restore the random number. It's like inside the algorithm that we're using, this assumption is. And the 2/3 assumption is used in practical Byzantine fault tolerance algorithm, but I'm not sure how did they come up with it and why does it work. I have to check that out. So yeah, about the resistance. Our consensus will be always under attack. So intelligent beings will try to crack it by different ways, by trying to make double spam, they will try to manipulate random. They will try to censor different actors, different nodes, or even make them up with time warp attacks. On the other hand, from engineering side, we have to try to avoid spam attacks, to make different mechanisms to protect ourselves from DDoS. And also we have to check data integrity corruption. For example, if someone sends you some wrong data or totally nonsensical data inside the message. Yeah, and one cool thing to keep in mind is uncertainty. So when you start working on your own consensus, you will have some mechanisms, and you don't know which mechanisms will work and which won't. So you have to assume that they work and build your way up to it slowly, like mechanism one by one. And in best case scenario, they will work. And in worst case scenario, you will like to revise not only the mechanism and the things that were relying on that mechanism. And also a good thing to know when you're trying to build your consensus is to split your consensus in layers. So because we are uncertain of different things in our consensus, we have to, for example, divide into different phases. The first phase will be proof of authority consensus. So we can make sure our random numbers work. And basically, we have the list of validators who are allowed to sign blocks. And that's it. Later, we may introduce ban for misbehavior. So for example, someone from initial list of validator will behave maliciously. We may ban him. Later, we may introduce penalties for different actions. And in the end, we will come up with the full consensus, even with economics and incentivizations. So I want to talk about our consensus a little bit, and I want to show you a brief demo of what we have done so far. So in our consensus, we have not only commit reveal scheme that I told you about, and we also have this publicly verifiable secret sharing scheme. It's the Shamir secret sharing we use that I answered the question about. We use the result of both these schemes to generate unbiased random number. We have a concept of time slots. It's a fixed frame of time where when validator is expected to send the block, or the block may be even omitted. It can be skipped. And we use a direct acyclic graph of blocks instead of flat chain. And this DAG, it's a short for the direct acyclic graph. This DAG has a possibility to have skipped blocks, I told you earlier. And it's always leaning towards one chain. And also we are thinking about mechanism of merging, so you can interpret history on the DAG like unambiguously, like you may think of it like of one chain. And yeah, that's it. I want to show you a little demo. I don't know, it's getting a little bit nerdy, but anyways, maybe it will be insightful. So yeah, here we have our simulator. So our simulator is a Python program which connects a few nodes which are following our consensus into this virtual network. And they are exchanging messages and trying to independently reach consensus on different things. And the first thing that we want to check is, can they reach this validator sequence independently? Like, does our blockchain provide the same random number for every node in the network. So yeah, it's in the console, I don't know, maybe it's not that useful, but here in the log you can see that we have this 47 node, for example, and it's the numbers of nodes which are going to be validators for the following epoch. And that's their numbers, and you can see that all nodes, including, for example, 48th node and 49th node, they have the same sequence of validators. And also, I can show you how we do merging. Like, it's also a beautiful picture, but I don't know how useful or insightful it is. So this is our chain, which is DEC. And we can see that, the cool thing that we do in our simulation is that we have not only usual nodes, which are properly doing like all these things they need, but we also have malicious nodes. And they are trying to apply different strategies to crack the network, to do double spans, for example. And here you can see this DAG. And you can see that node validators who were in the 9th and 10th time slot were trying to send not only a block they needed to send, but another additional block. And anyways, the blockchain, like the history of blockchain, merged in this block. And here you can see one type of attack is hiding block. This guy in the slot number 15, he didn't, like this node didn't immediately reveal its block and waited for 2 blocks to come, and then it revealed the block. But validator under number 17 like merged these 2 blockchains, and we have one history between in this time period. Yeah, I think that's it. If you have any questions, if it didn't go very technical, I will be glad to answer some. Sorry? What is? Yeah, it's also a usual thing for our consensus that block may be skipped. So 13 validator didn't send any block. That's it, and it's totally okay for our consensus because it's like semi-asynchronous, and everyone is okay with block not being sent. I don't know, maybe some other interesting situations happen here now. Yeah. Any other questions? Yeah?
Yeah, so you're building basically a new consensus algorithm for any projects to use?
For our project to use, but we're going to make a scientific paper. If it works okay, we're going to make a scientific paper for everybody to use. Yeah, but we are going to use it in our blockchain, and I think it will be Bitcoin-based blockchain, but not with proof of work, but with this proof of stake. This project is called Prometheus, I think, and I can show you its GitHub if you want to take a look. Yeah, it's Prometheus Python. If you want to take a look, maybe play with it a little bit. Yeah, it's nerdy. It's like programming, but it's Python on the other hand. And I hope it will be easy to understand. We are working on documentation of this thing. Yeah. Yeah, and the Bitcoin protocol, these Bitcoin-based blockchains that we are going to do will be in Rust. Yeah, so we are like testing our ideas in Python, and later on we're planning to port it into Rust. Yeah, and so this simulation is creating multiple nodes, and Rust will be like singular node to work with real network, because a network in the simulation is like a dummy network. They are just exchanging messages. Yeah?
Yeah, and also in a nutshell, can you just tell me what the main difference is between, I'm sure there are some, between the Tendermint proof of stake and what you found?
Yes, so that's what I was talking about. Tendermint is using this practical Byzantine fault tolerance consensus, and this consensus is synchronous as far as I understand. It has this thing with rounds. So for example, if someone is trying to sign block, he or she has to ask another people if this block can be signed, if they agree with this, and it takes time. So for example, if you scale this Tendermint, and you have more than 100 nodes, I think it will get slower and slower progressively. So if you have like 1,000 validators or more, it will be really, really slow. And also, this assumption of 2/3 of nodes be non-malicious is applied to PBFT consensuses, standard mint, and we try to make, like in Bitcoin, 51% of good nodes. And yeah, our blockchain, our consensus is like semi-synchronous because you don't need to wait for no one or nothing before broadcasting your block. Yeah, that's, I think, the main. Yeah, we're planning to go up to 50,000 validators. Yeah, so it will be more validators, not like in EOS when it's 21 validators only and it requires a very powerful computer to work. And we hope to make it run on the very weak PC and 50,000 validators in total.
And how it could be used in real life? Some right delegation or some permission or something?
It can be used, no, it's really just a payment system. You can think of it as a payment system, but the main part of it is it doesn't consume energy. For example, if you know in Bitcoin you have to mine, and it consumes a lot of energy. Everybody is not satisfied with it. And we try to address this problem. We create this proof of stake when you have to stake your money to be responsible of the works of blockchain, but at the same time it will be decentralized because 50,000 people will be involved in it. But from outside, it will look like it's a usual payment system, nothing really different from Bitcoin.
You're going to create your own, some currency?
Yeah, it will be our own currency. But if we publish scientific paper, you can create your own currency based on our consensus or even our Rust code, if you wish.
Well, actually, I can probably add to that. We, when we started our project, we thought that probably like every mistake that you can have, it's already made by Ethereum and Bitcoin, or mostly Ethereum. We started with the development, we already have the testnet, but then we understood that actually the consensus protocol doesn't work in Ethereum the way it would fit us, fit our needs. Then we dove deeper, and we understood that even proof of work in Bitcoin, like Bitcoin is an awesome thing, but its proof of work doesn't allow it to do many things that it really should do. So basically, we were kind of forced to create the basic level, the basic layer, which the consensus layer, and call it consensus. It's on proof of stake, and yeah, we already even talked to several maximalists, and you know their attitude to different kinds of proof of stakes and different kinds of projects which are not Bitcoin, but still we got the feedback that probably our consensus protocol is potentially not a scam. It's like the best thing that you can ever achieve from Bitcoin maximalism. Yeah, something. And answering your question, like how it can be used in real life, thousands of scenarios and use cases, like Bitcoin.
Yeah, what's your question?
Bitcoin is essentially just a payment system, right?
Yeah.
What about, how are you guys dealing, I don't know if you have planned for that or not, the interoperability of the different chains / smart contracts? Because if you're talking about the decentralized economy, and if that's the vision, smart contracts is definitely, I would say it's the main part.
Yeah, so we are going to use Bitcoin script basically. So everything what's done on Bitcoin script will be used on our blockchain. So you can imagine it like you take proof of work out of Bitcoin and put proof of stake in there, and that's it. So atomic swaps will work, Lightning Network should work, I think, and side chains, everything done for Bitcoin also will work.
Yeah, and also Bitcoin is not just a payment system, it's not just about payments, it's also about bridging the agreement within the network. And this is actually the hugest problems that we have now. I would say blockchain has now, or the industry has now, but there's no blockchain and no industry, so we have.
Yeah.
Yeah, so I'm trying to make sense out of this. reflection on what life could be about and how governments is made and how we are bound to the structure which we live in and which we are socialized in. And then on the second part we get some sort of technical insight in sort of a blockchain distributed ledger consensus mechanism system. But what's the outcome? So what's your vision to do with your technical part and the philosophical reflection in order to change something in this world? What's sort of the takeaway today in that sense?
I think Oля will answer it. Oh, I'm not philosopher. I'm technical guy. I'm just do code. No, could you please try?
Actually, the first part was more about like where we want to go, and the second part is how we want to go there. And basically, these are like the descriptions of the technical steps of achieving this goal. And first of all, is creating the open market of all that things that I talked about, like the open market of data sets, of algorithms, of kernels, of I don't know, everything. So yeah, this would be like the first step. And of course, we tried to start with this idea, and then understood that we can't use the existing consensuses. We came up with the idea of this Prometheus consensus because no solutions were found, and still we can't find any solutions for that. So yeah, this is why we're just layers and layers and layers and layers. But still, there are still levels that we did not touch. We're not planning to touch because, for example, one of our founders, he now has been developing his project, which would be launched based on ours. He is trying to replace all the programmers and developers with scripts, because he worked in IT field for many years, and he get tired of constantly explaining what to do, how to do to the programmers and everything, and controlling the outcome and everything. And basically, yeah, we're now preparing our project also as the basic level for those guys' application, for example. Yeah.
But the first step is the free market, the open market.
I guess the first step is the rules of the market. Like this consensus algorithm is like the basic one. If we talk about in terms of like which is more basic, which is less basic, so probably like the deepest level is the consensus, of course, the way that people and different kinds of agents reach the agreement. And then, of course, in the open market itself, like the top level.
And who are the stake nodes?
Stake nodes?
Yeah, like to do the proof mechanism.
Yeah, so stake nodes are basically people or programs running on someone's computer where money is frozen, who is responsible for network for network to work. I mean, they are signing blocks, and for signing blocks, they receive this little reward, like in Bitcoin. And if you have some money, you can put them, freeze them, and you will become stake validator, and you will sign blocks and receive this little reward.
But that is, in my eyes, the biggest problem of the proof of stake model, because it's like if you have the most money, you throw it, and you're the biggest stake.
Yeah, we get this question a lot. I think we have some mechanism for that. If I'm not mistaken, it will be some kind of lottery. Now, at first, I mean, like in the first epoch of our blockchain, you could not use all that money that you gain as block reward, so you won't get as rich as you could reach. And then some kind of lottery will happen, if I'm not mistaken, but it's like in the works, so money will get redistributed a little bit. But yeah, the problem still persists, but it may be not as bad as it sounds.
And after that, we have the reputation.
What we have?
Reputation.
Yeah, so we are planning to make a reputation. So this consensus, you may think of it like as a tool in the whole blockchain that we are building. So it will be a tool for our product, and the product is at first step an open market. And later we are planning to implement a reputation system in this open market. And you may do your computation, and these computations will be verified by another participants of the network. and they will get money and reputation for doing good for the network and something like that. So there will be a whole system, and I think we have a paper on it already, yeah?
Olga, you said about your founder.
Yeah.
He's trying to change your developers, like to use AI or
Yeah.
to create some neural networks.
Well,
Are you
as
using
I
blockchain?
said, like AI neural networks are like pretty much the same.
Or is there a set of algorithms?
I will be honest, I am not that familiar with the details, but the thing that I know is that he really wants to, well, of course for now he uses deep learning for doing that, for replacing the programmers.
So as far as I know, he just took the whole GitHub and put it like for neural network to learn, and out of that he tries to get some good result, like to replace the coder based on the history what coders did in the GitHub, something like that.
Basically, yeah, he uses neural network.
And what was your question? You had a question?
Yeah. So, I mean, actually following up on this question, like, there's not that much of a link between the first and the second presentation. I understand it's just a very big layer, and the first one is a pretty huge vision. So maybe in terms of story, there needs to be a better connect between those two pillars, let's say. And secondly, I'm still, especially in the technical side, where is the AI? I didn't get it.
So we don't have AI right now on the
Yeah,
technical
and
side.
the whole first presentation had a really huge focus on the AI, but in the project, I really don't see where AI fits in.
An open market, we're creating an open market for the AI, industry probably, right now. So we're not like AI project that, I don't know, sells some computations or buys algorithms or develops algorithms or, I don't know, does some neural network stuff, whatever. We're providing the ecosystem.
And the ecosystem that you're providing is focused on the AI applications, or it's just in general, because the societal sort of structure / governance and everything?
Let me probably just describe it. What field are you from? So that the example was very like close to your experience.
Machine learning.
Machine learning, okay. For example, you are a small business. You have a shop. Yeah, you have all the data for like 5 years, or you have the data collected for 20 years by firms or something like that. And you already made it digital, but you know some, I don't know, something that you need to improve. You want to, of course, improve and become better with your business. And now the only thing that you have, like the only option that you have, like probably 2 options. One is to hire the data scientist, which would just, like analyze all the data and create the kernel or find the kernel and like put the things together and then give you the outcome. But they are pretty much expensive at the time. And also for that you need computation power, of course. And for that you can't use your like PC. You really need to use, if you have that much amount of data, you need to go to Amazon or somewhere there. You need to rent computational power, and of course it's not like 1 cent per hour there, of course. And it's sure the server in Amazon, it will be shut down because they have no electricity. It can be destroyed, for example. The data can just vanish and everything, so it's very risky and it's very expensive and it's very slow.
But I already have the data, so I'm storing it locally. But I already have the data. The data is stored locally, actually.
Yeah, they're stored, but they're not processed.
Sorry?
They are stored. The data is stored.
Yeah, but I'm giving the data to the Amazon to do the processing, right? So the data is with me anyways. Data is not in the cloud.
Yeah, but how?
Wait, you need to upload data to the cloud.
Upload data, but I have the data already.
But we.
Data is not being lost. It's just, I'm using cloud just for the processing time.
But we have also this option to learn neural network, to teach neural network on distributed set of computers. So you can, like we are going to provide this open market. You upload your data to IPFS, for example, and then you pay some money for people all around the world to teach the neural network on your data in decentralized manner. That's like one of the usages of our open market.
And you get the outcome faster, and it's definitely verified already. And yeah, there is no single point of failure like the server that can just shut down while computing your other.
Does it make sense?
Yeah, this is one application. I mean, but the thing is, there are other people working like that, like Ocean Protocol is doing pretty well.
Yeah, yeah.
Actually, no motion protocol very well. Do you remember the thing that they had? Was it in the consensus or where was that?
I don't remember. They had some problems there.
Yeah,
I don't
we,
remember.
I'm not sure what was that, but I guess it was our consensus protocol. Yeah, we discussed, we were introduced to each other like a year ago probably. And at first we thought that we were like competitors, but then we understood that actually we have a pretty huge synergy because the consensus protocol that they have is not that good for their goals right now. And still, I'm not sure, but I believe the sensor, no? Like the design of the network. Well, I'm not sure. I don't know. So yeah, we are in more like in partnership relations, but not in a war or something.
Essentially, the only USP at the moment you guys have is the proof of stake consensus protocol, right?
The only one what?
The only thing that's different, you guys, is your own proof of stake development.
Can I answer from Ocean? You mean, right?
Not from Ocean in general, from blockchain ecosystem.
Maybe yes, but we are going to make this open market. And for example, I'm not sure about Ocean. I know about Golem. Have you heard of Golem project? It's basically the same thing. They are doing distributed computations, and you have this problem if you want something to be computed on someone else's computer, for example, you need to be sure that it was really done, the computations were done. And if you go and upload it to Golem and pay money for people to do the computation for you, they will do these overlapping computations to verify the correctness of the result. So someone will do 100% of computation, another person will do 100% of computation, and if it matches, you will get the result and you will show it is correct. And it costs you 5 times more, for example, because 5 people have to do the same computation. We are taking another approach and we are trying to split your computation, especially like neural network computation, into small parts and to give these little parts here and there to different guys. And also we'll do some overcomputing, but only for verifiers. So you can split into 10 parts, for example, give these 10 parts to different people, and then collect it all together and ask verifier to compute only some parts, like some 10%, and it will save you money and it will be fast. It won't be faster, it will be the same, but it will save you money.
It will probably be slower because then the distributed parts are going to different stakeholders, there's verification going on at every step. So I would think that would be slower as opposed to, you can do distributed computation using Apache and Hadoop, of course, that works. The only different thing is it's not doing it in a centralized way, it's doing it in a more distributed way where players are trustless. So but in terms of speed, I would say I think this kind of environment would be slower than the way it's done with the cloud.
I think it may be slower, but it really depends on how much parts you will get, I think. And if the smaller parts, they will be faster to verify. And if we have more verifiers, we can give them the smallest parts to verify. It may be not really that longer, like a little bit only. I hope so.
Well, Bitcoin actually is they're totally censored. You can be blocked, you can be all the phishing stuff, all this hacking and everything. The same risks. Yeah. So yeah, probably our system will not be like the perfect fit for like every case there can be, but it's pretty good start.
Maybe last one, why do you share your algorithms? It could be used in our company.
We're sharing what?
Your algorithms, how you automate my computer.
I would joke that it's the digital communism, you know, like everybody in blockchain field is sharing everything. It's like a good gesture. Everybody's doing that.
Principles.
Well, at first we were not generating neural networks and algorithms. We're providing the system and the market for that. Different kinds of agents, they come to this market and they interact with it by uploading or downloading the algorithms. And of course, they will be cryptographically encrypted. Sure.
And also, you have to share your algorithms because you want your algorithms to be verified. The more eyes looking at your code, for example, at your ideas, the more problems they will find. And it's like Bitcoin. It's community developed, and lots of different people found different vulnerabilities inside Bitcoin code, and they fixed them all eventually. We all want this thing also, that maybe we didn't see the problem there, and if we'll share, someone else will take a look and say, hey, guys, you have a problem there.
But code is rather simple. You said about like root repetition.
I don't get it. What do you mean?
What do you mean by saying
Do you
line
talk
is
about
simple?
some in our how to calculate some hashes or some keys?
Yeah.
It's not like Bitcoin essentially.
No, it's actually like Bitcoin. It uses practically the same cryptographical primitives and stuff like that. It just combines them in a little bit different way, and also introduces this Shamir secret sharing, which has never been used before, as I know, stuff like that. So it's like nothing really new there, but it's combined in this in unique way, I would say. Okay, any other questions? I see you have a question.
How do you expect the maximum amount of decentralization by using?
So we have this assumption that we will have 50,000 validators, like validator slots. It will be not an auction, but we will sort them by money they froze on the stake. But we think that 15,000 nodes is really a lot of people, and I think it will 5 and 4 zeros, like 50,000. Yeah, and it's a big number. I think it will help decentralization a lot because currently existing proof of stakes are bounded to like not more than 100, if I'm not mistaken. Maybe Cosmos. They told me they will have 100 right now, and in 10 years it will grow to 300, and that's it. So no other proof of stake is going to provide that amount of stakers, of validators. And also, I'm personally hoping that we will make a really fast node, so it could run on the mobile devices of the future, on routers, for example. I don't know, it's like my idea. So you can easily set up it on your router, and you will take part in decentralization. Unless a lot of people will put a lot of money there, so it will be like threshold to get there, but I hope they won't, or something like that.
But if processing data, it's going to be computationally intensive. How do you guys expect to do
So we are really planning to make this processing data part like a side chain to our chain, and it will happen in some other part of chain, and it will.
Slides actually, you can just
Yeah,
look at them
sure.
and describe. I think that would be better
Yeah.
because watching these 3 courses is not very productive.